Hello students, this is Mr. Ezra. Today we are going to talk about how to add and subtract rational expressions. As long as the denominator is the same, if we have like denominators, we're just going to add and subtract the numerators. And this is adding and subtracting like terms. So if I have 3x minus 4 over x plus 3 plus 2x plus 5 over x plus 3, the x plus 3 is going to stay the denominator. I'm only going to add the numerator. 3x plus 2x is 5x. Negative 4 plus 5 is positive 1. And again, x plus 3 is going to stay my denominator. Just like 1/3 plus 1/3 is 2/3, I'm just going to add those numerators together and it's going to stay x plus 3. And that is my answer. One more quick example with like denominators. X squared plus 2 is a like denominator. So here I'm subtracting. I want you to remember that when you have a minus sign, you must distribute the negative into the part that follows. So if I'm going to subtract all of 4x plus 4, I have to distribute that negative into 4x plus 4. So I'm just going to rewrite the top as 2x minus 1, subtract 4x, and then negative times positive is minus 4. And when you distribute a negative, just the signs change, and that's it. Our denominator is still going to be x squared plus 2. And now we can add like terms. 2x minus 4x is negative 2x. Negative 1 minus 4 is negative 5. And I get my final answer of negative 2x plus 5 over x squared plus 2. Well, when we don't have like denominators, we cannot add or subtract until we get like denominators. So before we jump in and start trying to do this with complicated things, let's talk about how to find the least common multiple, which is how we get the denominators the same. If I have a monomial in the denominator, then the rule is to find the least common multiple, which we call the LCM. You want to take the smallest number that they both go into, okay? So 3 goes into 3 and 6 and 9 and 12 and 15 and on and on. The smallest number that is a multiple of 3 that 2 also divides into is 6. And then for the exponents, we take the higher degree. So between x to the third and x to the fifth, we choose x to the fifth. Between y to the fourth and y to the third, we choose y to the fourth. And that is the least common multiple of these two monomials. When we get to polynomials, it gets a little bit more hairy. When we're finding the least common multiple of two polynomials that are larger than monomials, we have to factor both of them and then write each factor once as part of our least common multiple. Technically, if the quadratic has two factors, that should say TWO, two factors that are the same, we would write the factor twice. So if we're going to factor x squared plus 3x minus 4, we would get x plus 4 times x minus 1. Remember, when the leading coefficient is 1, you can just ask yourself what multiplies to give you your last term, but adds to give you the middle term. 4 times negative 1 is negative 4, and 4x minus x is positive 3x. And for my polynomial on the right, the quadratic on the right, I would get x minus 2 times x minus 1. So I've got x minus 2 times x minus 1. Negative 2 times negative 1 is positive 2, negative 2x. The inside and outside, negative 2x minus 1x is negative 3x. So I'm going to write each factor once. So x plus 4 is part of my least common multiple. X minus 1 is part of my least common multiple. And since x minus 1 is part of the factoring of the left side, I don't need to write it again when I get to it on the right side. I only need to write them one. The only time you would write it more than once is if you had x minus 1 2 times as a factor of one polynomial, and that's not happening here. So we're just going to write each factor once, and that is our least common multiple. Now let's embed this into our adding and subtracting of polynomial, or sorry. So let's embed this into our adding and subtracting of rational expressions. So when we're adding and subtracting, we need to get like denominators. To do that, that means that we must first factor the denominators. So I have x minus 1 over x squared plus 3x plus 2. This denominator is factorable, so I'm going to factor it first. It's going to factor to become x plus 2 times x plus 1. My right rational is already factored in the denominator. X plus 1 is as small as it's going to be. I'll put that in parentheses. And here is where we need to get like denominators. Now remember, when we said like denominators, we only write the factor once if it's a repeat from one to the other. So x plus 1 is part of both, so I don't have to write it again, but I do need both of them to have an x plus 2. Well, the one on the left has the x plus 1 and the x plus 2, but the one on the right only has the x plus 1. So what I'm going to do is I'm going to multiply the right side by x plus 2 on the top and the bottom. You know, really I'm multiplying this by 1 because x plus 2 divided by x plus 2 is 1. But I'm doing it so that I now have like denominators. I have x plus 1 and x plus 2 common in both terms. From here, I want to keep the denominator factored. I want to keep the denominator factored, so it's going to stay x plus 2 times x plus 1. Remember, when you add, once you get a like denominator, that's the answer. In the numerator, I'm going to kind of work this out a little bit. I've got x minus 1 on the left plus, and then I'm going to distribute this x into the x plus 2 that I multiplied up here. So x times x is x squared, and x times 2 is positive 2x. Let's get this in descending order. X squared. We got 1x plus 2x is 3x minus 1 over x plus 2 times x plus 1. It is perfectly acceptable to leave the denominator factor, and in fact at this point, if you can, you want to try to factor the numerator. X squared plus 3x minus 1 is non-factorable. We're not able to factor that, so we can stop here and circle this answer. This is the sum of the two rational expressions. X minus 1 over x squared plus 3x plus 2 plus x over x plus 1 gives us this rational expression here when added together. So factor first the denominator. And after you do that, you want to get like denominators, which means that you might have to multiply sometimes to get there. And then finally, add them together. That is it. That's the big secret. Example number 6. We've got 2x squared minus 16 over x squared minus 4 minus x plus 4 over x minus 2. We want to factor both denominators first. So we'll leave the numerator. We're not going to touch it yet. We're going to leave it 2x squared minus 16. But we're going to factor the denominator. And this is the difference of two squares. And difference of two squares, you take the square root of the first and the second. In this case, that's x and 2, and we put x plus 2 times x minus 2. On the right rational, we already have the x plus 2, right? I'm going to put that in parentheses, just so when I multiply, we can know what to do. So I already have the x plus 2, but I don't have an x minus 1, and they have to be part of both, so I'm going to multiply by x minus 2. So I have the x plus 2 already, but I don't have the x minus 2, so I multiply top and bottom by x minus 2. And what this allows me to have is a common denominator. Now I have common denominators, and I just have to work on cleaning up the numerator. So I've got 2x squared minus 16 minus, and I'm going to put a parenthesis here because it's minus all of this, and I have to multiply these two things together. I'm going to FOIL them. First, outside, inside last. And I'm going to use a little bit of shortcut. So I'll start with the first, which is x times x. And I'll do the outside and inside together. So minus 2x plus 4x is positive 2x. And then I'll do last times last, which is negative 8. All of that is over our common denominator of x plus 2 times x minus 2. Let's fix this up just a little bit. So now that we've got our common denominator and we've got our numerator listed out, pay attention to the fact that I put minus parentheses because I'm subtracting this whole thing. And what do you do when you subtract a parentheses? You distribute into that parentheses. When you distribute a negative, it just changes the signs. So what we actually have here is 2x squared minus 16 minus x squared minus 2x. And then negative times negative is positive 8. And again, all of this is still over x plus 2 times x minus 2. Running out of room. We'll scoot down a little bit. Now we want to clean up the numerator. And to do this, we're going to put together like terms. So we've got x squareds that can go together. 2x squared minus x squared is 1x squared. We've got minus 2x over here. And then the constant minus 16 and plus 8 go together. Negative 16 plus 8 is minus 8. All of this is over x plus 2 times x minus 2. We see a polynomial on the top, a quadratic on the top, that may be factorable. In the last example, it was not factorable, but this, I think, might be factorable. So let's see if we can factor it really quickly. Scroll down a little bit more. We have, let's see, x. I need something that multiplies to give me negative 8 and adds to give me negative 2. Well, I know 2 times 4 is 8, and they're 2 apart. So if I put a minus 4 here and a plus 2 here, that would give me something that multiplies to give me negative 8, but adds to give me negative 2. That's going to work. Over x plus 2 times x minus 2. Now, the reason that you want to factor every chance that you get at the end of the problem, we wait to do this until the end, and now we factor the top, is because sometimes things cancel out. In fact, this time the x plus 2's cancel out, which leaves us with our final answer of x minus 4 over x minus 2. And since so much canceled out, I don't even need parentheses. So let's kind of back up here and just review really quickly what we did. Yeah, we started with our problem. We factored the denominator first. We do not factor the numerator till the very end. After factoring the denominator, we got what we call a least common multiple. Once we know what the factors are, anything that's missing on either of the terms, we multiply top and bottom by that. When you multiply the top, we had to FOIL and then distribute a negative because it's subtracting. You always distribute the negative when you're subtracting there. Put together like terms, we have another quadratic that is factorable. We factored it and noticed that x plus 2 canceled out, leaving us with this very simple rational expression here, x minus 4 over x minus 2. All right, we're almost done today. Got a few more quick, or maybe one more quick example to review complex fractions. Complex fractions are called complex because they are when you have fractions inside of fractions. And this is a pretty simple one, but sometimes they can get a little bit more complicated than this. We have this fraction divided by this other fraction. How do we deal with it? Well, the first thing I want you to remember that a fraction bar is the same thing as dividing. So we talked in the last lesson about how to divide rational numbers, that instead of dividing them, you're actually multiplying them. We called this keep, change, flip. Okay, so I'm going to rewrite this first as division and say this is x plus 2 over x minus 1 divided by x minus 3 over x plus 5 And I'm going to keep the first one, change the division to multiplication, and flip the second one. This is also called multiplying by the reciprocal, so that we can actually multiply. We cannot divide fractions. Instead, we multiply by the reciprocal. So that's going to be x plus 5 over x minus 3. Well, now that we've got this, when we multiply them together, notice that nothing is the same. There's absolutely nothing that we can cancel out. It's all going to stay as part of our answer. You want to reduce if you can, always, and as your last step. Here we can't. So our final answer would actually be x plus 2 times x plus 5 over x minus 1 times x minus 3. And as usual, it doesn't matter if the x plus 5 is first or second, if the x minus 1 is first or second. The order on the top or the bottom doesn't matter, but you need to have both binomials in the top, both binomials in the denominator in order to get the correct answer. Well, that's it for today. As you're practicing, if you run into any problems that are giving you trouble, that you're having trouble with, please let me know and we'll look at it together. Hope that you're very successful with adding and subtracting rational expressions, and I'll see you in class.